if we have two forces, this is F2, this is F1. Note that their starting point, it is not at the origin. We need to put it at the origin. We can't drag them to put them anywhere we want. This angle is 40. This angle is 45, 45, yes. F2 is equal to 50 newtons. F1 is equal to 20 newtons. And the mass is equal to 50 kilograms. There's a mass here. We need to put our forces as vectors at the origin. So this is F1 will be like this. And this angle 40 will be this angle 40. Right? What about the other one? F2, this is F2. This is 45. Or this also is 45. I need to find the acceleration. I have two-dimensional motion now. What I need to do, I need to find A as a vector, which is AX I hat plus AY J hat. I have also Newton's law, F is equal to ma. So A is equal to F over m. A is equal to F over m. It is equal to Fx over m I hat plus Fy over m J hat. Right? I feel like this. Okay. طيب. I have forces with angles. I need to find the components of each force. I'll draw it here to make it simpler. This is F1 equal to 20 newtons. This is 40. This is F2 equal to 50. This is 45. If you need to deal with the length of the vector, 20 is not equal to 50. It is almost half of 50. So this is 20, almost. Right? Now I need to find the component of each vector on x-axis or on y-axis. Here, this is F1x, which is equal to F1 cosine the angle, because I'm dealing with the axis with x-axis with the direction of that angle. Cosine 40. What about this component here? This is F2 x, which is equal to F2 cosine 45. What about the y forces component? This is F1y is equal to F1 sine 40. What about this? It is F2y, which is equal to F2 sine 45, right? I think the answer is right. Now, what is Fx, Fy? I need just to put, this is 20. cosine 40 by the calculator. F2, it is 50. And here, 50. I can compute everything now. By that, I can find F1x. F1x and Fyx, F2x are in the positive x direction. Now, let's remove this. Now my force is Fx I hat plus Fy j hat. Okay, Fx is equal to, which is the summation this one, we have a summation, it is equal to F1 cosine plus F2 cosine. This will be equal to 50.68 newtons. And the forces on y direction, one of them downward, which is F2 sine 45, one of them is F1 sine positive direction. It will be equal to 0.96, almost 1 newtons. Our force now is 50 in positive x and 1 in positive y. So this is our force. It's a little bit, we can add them together by doing this. This is our force. It is 50 and 1. 50 in x, 1 in y. Can we find the magnitude of that force? Yes, we can. F is equal to the square root of 50.68 square plus 0.96, I think, square. Theta is tan inverse to 0.96, which is the y component over 50.68. Okay, what about the acceleration? I'm asking about the acceleration from the beginning. It is simple. The mass is, how much the mass? The mass is 50. Okay, the acceleration, it is the force component over 50. So this is over 50 and this is over 50. I have it. Fx is 50.68 and here it is 0.96. This is Ax and this is Ay. Also, I can find the magnitude of the acceleration and the direction of the acceleration. The direction of the acceleration will be the same like this. You can see that. Any question about this example? Matt?